Okay, here's what we're up to. We're given that f of x equals x squared minus 4, and we have to find the equation of the tangent line to f of x at the point 1, 4. And to do that, we'll use this equation, m equals the slope equals f of x plus h minus f of x all over h. And we'll use that equation to find the instantaneous rate of change. Once we know the slope, we can use the slope and the ordered pair 1, 4 and employ the point-slope form of the line to get the equation of the tangent line. So let's get started. We know that f of x equals x squared minus 4. And let's see, now f of whatever equals whatever squared minus 4. If we put an x plus h here, then we have to put it there. And now we're ready to construct this equation. So m equals, and in place of f of x plus h, we'll substitute this fellow, but we'll square out this x plus h. And as you know by the FOIL method, if we were to square that, we're going to get x squared plus 2xh plus h squared minus that 4 and minus f of x, but f of x is x squared minus 4. It's important you install the parentheses so you remember to distribute that negative. Downstairs we have an h. So we have x squared plus 2xh plus h squared minus 4 minus x squared, and minus times a minus is a plus 4, and our denominator is h. And notice, the x squareds are opposites, so they have add out. The 4s are opposites, so they add out. And now we're left with 2xh plus h squared all over h. At this point, we will factor out an h. And we're left with, in the parentheses, 2x plus h. Downstairs we have an h. Now these factors of h divide out. So now we have 2x plus h. At this point, in order to find the instantaneous rate of change, we'll let h become 0. So we're going to let h equals 0, and now m, the slope, equals 2x. Okay, so we have that the slope equals 2x. That's the slope of the tangent line at any point on the curve. And the point we're interested in, xy, is 1, 4. So the x-coordinate is 1, the y-coordinate is 4. So to find the slope at 1, 4, we'll replace x with 1. So the slope of the tangent line at the point 1, 4 is 1 times 2 is 2. Now we have the slope. We also have the point 1, 4. So we can employ the point-slope form of the line. And for y sub 1, we'll substitute 4. For m, we have a 2. And for x sub 1, we'll substitute 1. And now let's simplify this, and we get y minus 4 equals 2x minus 2, distributing the 2. Now we'll add 4 to both sides. Y equals 2x minus 2 plus 4. So y equals 2x plus 2. And that is the equation of the tangent line to the curve f of x equals x squared minus 4 at the point 1, 4. So for the second question, we're given that the limit of the square root of the quantity x minus 1 as x goes to 5 equals 2, and we have to find delta, which is greater than 0, for an epsilon which equals 1, and we'll use these two inequalities to do so. So the first thing we'll do is install f of x, and f of x is the square root of x minus 1. The limit is 2, minus 2, and that's less than epsilon, but epsilon is 1. And now let's dispense with the absolute value bars. So we get negative 1 is less than the square root of x minus 1 minus 2, which is less than 1. Now we have to isolate this radical, so we'll add 2 to each interval. Adding 2 to negative 1, we get 1. Adding 2 to this interval, we just get x minus 2. The 2's add out. And adding 2 to 1, we get 3. Now we have to dispense with this radical, so we will square each interval. 1 squared is 1. Squaring this, we get x minus 1. Squaring 3, we get 9. Now to isolate x, we'll add 1 to each interval. And so 1 plus 1 is 2. Here's our x. 1 minus 1 is 0, plus x is x, and 1 plus 9 is 10. Good, that part's done. Now we'll go through the same process here. So we have the absolute value of x, and x sub in this case is 5. And that is less than delta. So our first task is to dispense with the absolute value bars. So to do so, we'll add a negative delta to the left, install an inequality, less than x minus 5, which is less than delta. Now we have to isolate x here, so we'll add 5 to each interval. So 5 minus delta is less than x, which is less than 5 plus delta. Now, with that done, we can equate like positions or corresponding positions. So let's do that. 2 equals 5 minus delta. Let's add delta to both sides and subtract 2 from both sides. In so doing, delta equals, and 5 minus 2 is 3. And now let's equate 10 and 5 plus delta. So we have 5 plus delta equals 10. Subtracting 5 from both sides, we'll have delta equals 5. Now, we've got two different values of delta. We need to write delta in some form that satisfies this given equation and limit. So we'll let delta equal the minimum of 3 or 5. And we're done.